Perfect. Thank you, Otto. So let me go ahead and share the screen. All right. So up on screen, we have EdgeWise. And so what we've done up until this point is we've taken our scan files, we've ran our registered data through the software, and EdgeWise has gone through and extracted piping. So all the pipes that you currently see up on screen, this is all automatically generated by the software with zero human intervention. So this is purely the result of automation right here. So the first key tool I want to introduce inside of EdgeWise is going to be our QA/QC tools through the part info spreadsheet. This is an intelligent spreadsheet that links my numerics back to my visual model. And coming back to that concept of QA, in the QA mode, I have the bore of the extracted pipe in gray, and in this teal / kind of green, I have all the points used to extract that pipe. So I can very quickly scroll through doing a visual inspection of my pipes, and that way I can ensure the highest level of accuracy in the geometry fitting the point cloud. The next thing I want to talk about is gaps. What I mean by that is laser scanning is a line of sight, which means basically if there's like something like structural steel, like blocking the scanner from seeing the pipe behind it, again, no data, no pipe. So instead of having to go through one by one and do these connections manually, we can leverage the automation through something called the Easy Connect tool. And the Easy Connect tool is where EdgeWise will automatically go through and insert both straight connections as well as elbow connections throughout the model. And there you can see in black, that's everything the software just did right there. Continuing on with the theme of automation, we then have the Clean Pipes tool. So the Clean Pipes tool is rather unique and that has a tolerance. And that tolerance allows a user to control either how as built or how as designed the model will be. And I can make either I could do a more straight, perfect pipe run, or I can make my pipe runs more as built, so have more sags and more deviations captured. I can do that at either a project level, or I can do that for individual pipe runs. Next up, to apply standard, I can use my apply standards option right here. These are all the standards that come with EdgeWise outside the box. We also have a standard editor that allows you to add your own custom standards. But the way it works is choose a spec from the list, click OK, and this is where EdgeWise will take the diameters that it found from the scan data and matches them up to the closest standard spec diameter. The last thing I'll show before we talk a little bit about the export is our second spreadsheet, and that's going to be the chain info spreadsheet. The chain info spreadsheet allows me to manage the intelligence relating to the whole pipe run, including pressure rating and standard information, diameters, and for any of the Revit users out there, we can also control the families. So that way, inside of Revit, we can export as one of 3 different family groups. We could do either pipes, conduit, or circular ducting, and that way it'll come into Revit under that correct family database. Now, let's go ahead and talk a little bit about the exports. So for the exports, we have a variety of different ones. I'm going to go ahead and start from the bottom, and then we'll kind of work our way up. The last 3 are going to be kind of our primary CAD exports, and that we have step. Step is going to be the 3D geometry, as well as we also have center lines and routing lines for AutoCAD. That'll be our line work. Smart Points is actually a unique export, and that's a point cloud export from EdgeWise. What Smart Points allows us to do is we can basically filter out all the point cloud data not associated with, say, like pipes or structural steel. And that way we can create a point cloud that only has the points relating to the objects that we're interested in. So that way, inside of like Revit or Plant 3D or whatever application we're going into, instead of having to work with the whole point cloud, we're only working with the point cloud data associated with like our pipes. Next up, we also have Plant 3D. There is a specific plugin that we can use to bring everything from EdgeWise into Plant 3D as Plant 3D objects. and then also PDMS for the Aviva ecosystem, and we're currently working on an Everything 3D plugin. Revit is right here. We also have a big export to Revit, and that'll basically take everything and imports it into Revit as true Revit family objects with all the intelligence and everything you would expect. So that right there, that's going to be the piping side of the software. Guess, Otto, you wanted to jump right in the structure?
Yeah, let's get it. Unless there's any questions. If not, we could go right into structure.
If not, we can take questions at the end. So, all right.
Right. Okay.
Structural steel. Structural steel actually operates off of a different engine, and that engine is object detection. So what that means from a practical standpoint is the automation, instead of happening at the beginning of the software, actually happens more towards the end. So with structural steel, the way it works is we'll go over here to our structure tab, and we have the extract tool. So the way we can work the extract tool is we'll draw a box around the point cloud data that makes up the piece of steel that we're trying to create. And then EdgeWise will go out to a catalog, in this case, the AISC steel catalog, and then choose from the catalog the member size that fits. And there you can see right there, there's this piece of structural steel we just created. Next up, we have that all-important concept of QA/QC through the Smartsheet. So inside the Smartsheet, I can see everything from like the size, basically all my numerics. And over here on the left, I have the 2D view where I can see the outline of my steel in white that I can manipulate. And in green, I have all the point cloud data around it. So in this case, I'm actually going to tweak the size a little bit using my resize tool. So using our Smartsheet, it becomes very easy to resize my structural steel like so, where I can quickly go through and basically resize it and readjust it, again, to ensure the best possible fit between the geometry and the point cloud. So now that I have that beam created, I'm going to go ahead and extract the one above it, like so. Again, using my extract tool, I'll draw the box. Now with these two beams created, I'll then use my extend tool to extend these over and build this little section here. And now that I have this section complete, this is where I can go ahead and leverage the automation. So if you'll notice, this is a repeating series of members over to the left. And I can take advantage of that with something called the pattern extract tool. The pattern extract tool, what it is basically it's where I can select a grouping of elements in green and then set a direction and a spacing. What the software will do is it'll go out at that set direction and at that set spacing and look for those elements. As it finds the elements in the point cloud, it'll do a true mass extraction, fitting each and every element individually to the point cloud to get you your as-built conditions. In summary, the tool is basically an intelligent array tool. And instead of just doing a blind copy and paste, maybe 10 times every 3 meters, it actually leverages the point cloud data to get true individualized fits for all the different pieces of geometry. So there you can see in green right there, that's the result of the automation with the pattern extract tool. And again, each one of these is actually individually fit to the point cloud. So that way we can turn the point cloud back on and verify using our QA tools that again, we have that accuracy fitting back like so. So that's going to be the structural steel portion inside of EdgeWise with the pattern extract tool for the automation. Another module that we'll go ahead and talk about for today is going to be cable tray. So with cable tray, it works kind of a lot more similar, I guess you could say, to the structural steel portion. So with that, let me go ahead, switch over to my cable tray point cloud right here, and we'll take a look.
Yeah, let me just say real quick, the cable tray and the ducting are very similar, right? So ducting is enclosed on 4 sides and cable trays are typically enclosed on 3 sides. So what Trevor's going to show you with the cable tray, the ducting is very similar to that. So in interest of time, we'll show the cable tray, okay?
Yep. So right here, we have kind of this section of cable tray present in our point cloud. So the way it works with cable tray is that if we can extract out our straight segments, then EdgeWise will help us do the transitions as well as the elbows. So I'll go ahead and use that same extraction tool like I had previously with the structural steel, and I'll go through and basically create my straight sections of cable tray like this. And once again, I'm basically just drawing my extraction box around and creating my sections like so. So I'll go here, and then I'll go ahead and extract out this last piece over here. We'll go something like this. So now with my cable tray created like that, what I can do is come over here to kind of one side of my run. And with a pair of cable tray selected, I can go ahead and choose what connection I want. In this case, I'll go ahead and use a mitered elbow and basically work my way along the run like so, inserting my connections as need be. And then once I do that, I can turn, oh, oops. I go ahead and actually squeak that over a little bit, make a little bit more room for the elbow like that. There we go. And then I can turn my point cloud back on, again, to verify the accuracy and the fit of my cable tray, again, like that. So that's going to be the cable tray module. Once I do my cable tray, again, just like a piping as well as the structure, I can export this out into a variety of applications as either like three-dimensional solids through step, or I can export this into Revit as intelligent using the export to Revit command right there. So one key thing I will mention, actually, regardless of whether or not it's like the piping, the structure, or the cable tray, is going to be positioning. So where does the geometry actually come in space? The answer is basically through the point cloud. Anything created by EdgeWise will be in the same position of the point cloud. So that way, whatever application you're modeling into, as you model your different systems, like, piping, structural steel, whatever, as it comes into like Plant 3D, AutoCAD, or Revit, it'll come in correctly aligned. And then at the end, you should be able to drop in your point cloud, and then everything will be correctly aligned in your end application. Lastly, no matter what application you're going into, there's no, I guess you could say in a way, like link back to EdgeWise, and that once it's inside of like Revit or CAD, at that point you can save out the project or the drawing, and it's basically at that point it's fully in that end application, so you can send it over to the rest of your teams, and that way they can continue on modeling it, adding on additional detail, exactly the same as if it was natively created inside of like Revit or AutoCAD. Yeah, so that is, I guess you could say that's the piping, the structural steel, as well as the cable tray sections of the EdgeWise software. Yes,
Okay.
Otto.
Yep. Okay, so we covered, most of the basics. We could cover the building, but on the building, we basically extract the walls to an as-is condition. Trevor, if you want to show that real quick, how we could bring that in, that would be ideal too.
All right.
And then we can move on to Verity.
Yep. So with the building portion of the software, the building portion is probably the most specialized out of all the EdgeWise modules. And then basically it's designed to be a quick way to extract out like wall positions, bring those into Revit, and then inside of Revit we can use that to generate like quick floor plans for quick floor plans inside of Revit. So here's an example of kind of the result of the automation for the building side of the software. It looks something like this. So there we can see if I turn my point cloud off, these are the walls that EdgeWise has extracted out. So once I have my walls created, basically I'll do like a little bit of cleanup and kind of, delete a little false positives. In this case, things like doors, or we had kind of some equipment that basically went floor to ceiling and kind of looked enough like a wall. So once I have my outline kind of cleaned up and adjusted like so, this is where then I could export out my wall positions from EdgeWise into the Revit application. And then inside of Revit, this would all come in as EdgeWise family walls that I can then adjust and then use that for quick floor plan generation inside of Revit. Yeah, that would be the architectural side of the software. And that's basically kind of the four main modules inside of EdgeWise. I will share my screen now. All right. So as the screen kind of gets fired up, Verity is construction verification for Navisworks. So the main thing with Verity is the starting point is actually going to be inside of the Navisworks application. So with that, we have two things loaded in. Number one, we have geometry. Number two, we have the point cloud data representing our as-built. So with these two things loaded in, we'll go ahead and begin our Verity workflow. So the first thing that we'll do is we'll grab the geometry as well as the scan data that we want to compare against. So any kind of geometry is going to be fair game so long as that's 3D geometry inside of Navisworks. So with everything selected, I'll go ahead and import all this from Navisworks into the Verity application. And again, I really want to stress that Verity does not do modeling. Verity is not a modeling tool. Verity is a comparison tool. So again, as long as the geometry exists inside of Navisworks, it doesn't matter if it's like an I-beam or a pipe or like a piece of equipment, you can compare that geometry against the point cloud. So all right. So here we have Verity itself. So with the Verity application opened up, once we have our geometry and our point cloud loaded in, this is where we can go ahead and do an analysis. So for the analysis, I'll set my tolerance. In this case, I'll use about 1 centimeter. And when I click OK, this is where Verity is going to go through and say, is the geometry found within the point cloud, i.e., has it been built? If it's not, it'll flag it as such and say, hey, this is missing. And if it is built and it does find it, it'll say, is this piece of geometry inside of tolerance? If it's in tolerance, good, great, well done. If it's out of tolerance, Verity will create a copy of the geometry. And that copy of the geometry, it'll refit back to the point cloud to show you the true as-built location of what should be there. When Verity is done with the analysis, the first thing that opens up is this right here, the summary report. The summary report is basically a pie chart overview, letting you know the results of what Verity has found. So in this case, we have some not founds, and it looks like the majority is out of tolerance. Coming back to the Verity application, if I click on one of my items, I actually have a couple things. You'll notice I have the point cloud data in white, and if I turn off my points, I have two pieces of geometry. The purple represents the design condition, or the element as it currently sits inside of Navisworks. The cyan or teal represents the copy of the geometry that Verity has created and refit back to the point cloud to show you the true as-built location of what actually got installed. In addition to the visual, you'll notice at the bottom, I have my item table where I can see my metrics. So for example, I can see the installation status, this is installed, and versus 1 centimeter, it's currently out of tolerance. Furthermore, scrolling to the right, I have additional translations where I can see the total translation. In this case, about 17.4 is how far the element is moved in the worst spot before it breaks that number down into the different components of that translation. So now let's go ahead and talk about kind of the actual Verity workflow. So the first tool I always like to introduce inside of Verity is going to be the split view. The split view splits the camera into these 4 summary views that can very quickly see how the geometry is fitting to the point cloud. On the subject of the point cloud, Verity will also go through and classify the point cloud data around the element, and what it does with that classified data is it generates heat maps. So Verity will create one of 3 different heat maps. In this case, the main one I like to show is going to be the as-built heat map, which shows how the point cloud data fits the as-built or the best fit geometry, where you can see green is good, yellow and red are points too far away from the element, and blue's points that are too close. So in a combination, I can use my heat maps as well as my points turned on like this. I can go ahead and QA, QC and review my element. And then I have 2 little columns down here, action required and notes. So these are just text fields where I can type in whatever information I would like, and that will now get exported in the report. So after checking my element, I can go ahead and accept the status. That puts the status to reviewed, puts my initials in the reviewer pane, and basically I can go through and kind of work my way down, checking my elements like so. After my QA/QC process, this is where I can now take the information out and put it back into Navisworks as well as a variety of other applications. So, kind of to show a little bit of that, let me go ahead and get the screen kind of side by side. And so one of the key things is actually going to be working in Navisworks and Verity simultaneously. So as part of that, the selection is bidirectional. So that way, if I have a piece of geometry selected inside of Verity, I can see that same selection inside of Navisworks and vice versa. So again, that way I can sort and select elements in Verity based upon like tolerances or item classifications. And that way inside of Navisworks, I can use that information to build selection sets for then say clash detection and coordination. Besides that, we can also kind of work in both simultaneously using either like the section box command to quickly isolate elements to find it, or we can use the match view frame to quickly link up the camera between both software applications. So that way we can work in Navisworks to see the element in context of the whole project, and then we can work in Verity to see the element kind of by itself. And so after working, now we can then do kind of the next thing, and that's going to be taking information and actually pushing it back to Navisworks using these two options right there. The first one will show does two different things. Number one, you'll see it actually color codes the geometry inside of Navisworks according to the tolerance. In this case, my yellow pieces, those represent out of tolerance members. In addition to the color codes, Verity will also go through and actually create a properties tab inside of the element, and it'll push over all the metrics it found, and that way these metrics will now be hosted as part of the properties inside of Navisworks. And now we have the second key one, and that's going to be the button right here that looks like two I-beams. So if you watch the pipe over here on the left, at the click of a button, you can see it moves. So Verity will take and actually apply the as-built transform. So I can do this one at a time, or I can do it for, say, all the items in my analysis at once. This is about 17 items, but if you can imagine doing like 700 items, this is quite literally how I can convert from as designed to as built inside of Navisworks to get accurate models for clash detection and coordination. So quite literally, I can convert at a click of a button. All right. The last thing I'll go ahead and show kind of inside of Verity is going to be some of the reports. So there is a publish tab. So we do have integrations with Procore, BIMTrack, as well as BIM 360 Field. So that way you can take the Verity results, push them as issues into your kind of project hub, and that way everything can be controlled and kind of managed in one central environment. We also have our native reports for that. We have kind of the more common ones like CSV, HTML, and PDF reports right here. And the big one I want to kind of talk about real quick is Smart Points. To actually show Smart Points, I'm going to switch over to a different project real quick. And so Smart Points is actually a point cloud export. So using Verity, one of the common things that can happen is, say, for example, I run like 100 I-beams through. We're out of tolerance. What Smart Points gives us the ability to do is we can select just those 10 I-beams and export out the point cloud data only for those. And so that way we can then take that point cloud, bring it back into like Revit or AutoCAD, and then say, hey, this is everything that's out of tolerance. Can you please update this? So there you can see over here on the left, here's an example of a heat map based upon like a 3 centimeter deviation. So again, that way it makes the point cloud a lot more kind of I guess you could say it trims it down and makes it more intelligent. So that way I can kind of show as-built deviations, quickly like that. And that right there, that basically wraps up as a quick overview of the Verity application.